Welcome to today's webinar, Ethical Hacking and Secure Coding. My name's Etty. I'm a part of the marketing team here at StayAhead. We'll just give it another minute or so for a few more people to join us, and then I will be handing over to Stuart here, who is one of our lead web developing and programming trainer, who will be taking you through the main presentation today. So before we get on to that, I do just have a couple of housekeeping bits to run through. Apologies in advance to those of you that joined our earlier sessions and are hearing it for the second, if not third time today.
Sorry, Etty, can I just apologise? Yes. Your housekeeping slide is not here. That's my bad. So
sorry, that's on me. I'll just talk through. They're only little icons anyway, so you're not missing too much. So yes, you'll notice that you've come in on mute. Please do stay that way. I don't believe you have the option to, even if you wanted to, unmute yourself, but if you do, please don't use it. If you do have any questions as you're going through, though, there is a little question box up in the top right-hand corner of your screen. So if you have any technical problems, if you can't see us, you can't hear us, then I will kind of handle those in the background. And if you have any questions about the content, please feel free to pop them in as we're going along, but Stuart will be answering them at the end as part of our Q&A. The webinar is being recorded. We will send over a link to that on Monday, so you should get an email through, and you can watch it back as many times as you would like, or share it on with colleagues, anybody else that you think might find it useful. We also like to say give us a follow on LinkedIn. We're active as @StayAhead. And you can find out a lot more information about our new courses, any other upcoming webinar sessions and events and stuff like that that we are doing. You'll be the first person to hear about those. So today's session should last about half an hour. And then, as I said, we've left about 10-15 minutes at the end for a Q&A, so we can answer any of your questions. So without further ado, I shall hand you over to Stuart here, who will take you through today's presentation.
Thanks, Etty, and welcome all. My name is Stuart. I teach a range of coding courses at StayAhead, mainly centered around our three primary languages, Python, Java, and JavaScript. But we do lots of courses around the edges of that. The webinar here is about ethical hacking and secure coding, and we're looking at some common attacks and how to protect against them. These particular attacks that we've chosen have been around for a long time. But they're still very common, and it seems to me, teaching that there are sort of beginners coming through who are not necessarily exposed to these things, perhaps the way that they might have been done in the past, because a lot of developers are using tools and frameworks that include mitigations out of the box, and that's a good thing. But I still think that it's worthwhile, indeed important, that developers understand these vulnerabilities, or aware of how they happen, and the basic steps that one can take to protect against them. And so that's what we're focusing on. So of course, there are many ways in which a web application may be deemed vulnerable or hacked. We're going to look at three very common cases today, namely SQL injection, cross-site scripting, and cross-site request forgery. We will talk a little bit about those, or introduce those three hacks first. And then I'll provide a live demonstration where I will demonstrate the hack. We'll look at the vulnerable code, and then we'll look at what steps one would need to take to to fix those vulnerabilities. The application that we will be looking at is written in Python largely, but it doesn't really matter. The language in which the code is written is not really important. The hacks are performed in the same way, regardless of the language, and the fixes are the same, regardless of the language as well. Now, we will be looking at some code, but you don't need to be technical. I think you will grasp the concepts. So don't worry if you don't understand the code directly. So let's start with SQL injection, and indeed with a definition of SQL itself, for those of you who don't know. So SQL, or SQL, is short for Structured Query Language, and it is the language that is used to read from and write to a relational database. And most applications will store data in a relational database, so that they are extremely common. And there's some example SQL code here. So this first example is a read operation that is reading all of the users from the users table where the username is Stuart. In all likelihood, there's only there may only be one. The second of the statements here is performing a write operation. That is, it is adding a record to a database table, to the users table specifically, and we can assume that the users table includes at least two columns, one for username and one for password. I should note, if I'm being thorough and comprehensive here, that we don't advocate for the storing of plain text passwords. It's bad practice, and most good web application frameworks will prevent you from doing that. I'm just keeping the example simple. The final SQL example here is a statement that will delete from the users table where the username matches some given value. And I've ended with this particular example because SQL injection is a hack that relies upon poor quality SQL code, where we take a user given value and we embed it into the SQL without doing any checks, without ensuring that it is legitimate. So a hacker will exploit poor quality SQL code to do something he or she ought not be able to do. So SQLI, or SQL injection, is where malicious SQL code is injected, in inverted commas, usually via web application form field, or maybe a URL or something like that. So for example, you may have a form on your web page where the user can enter his or her username. If the user is malicious and knows SQL, then he or she can enter SQL code into this text box instead of a real username, and that may enable him or her to either bypass security and steal or destroy data. So this is really serious. The fix is very simple, but it's a really serious problem, and I'll demonstrate to you in a few minutes just how easy it is for a hacker to get in to a web application using SQL injection. The second of the three vulnerabilities we're going to look at depends upon web application scripting. And a web app script is some code that exists in a web page and that is executed by the browser. Now, the language that is typically used to do this is JavaScript. So JavaScript is code that can be added into a web page, and when that web page is loaded by a browser, that code gets executed by the browser. And most of the time, thankfully, scripts are added to web pages for good reason. So we would add scripts into a web page to make the application dynamic and or interactive. So, for example, on this line of this is HTML code by and large, but the highlighted code here is JavaScript code, which is executed by the browser when the button is clicked. And as I say, JavaScript code is very important. It has enabled the rise of web applications, and generally it's used for the purpose with which it was intended. But a problem occurs if a hacker is able to insert malicious code into the web page that does something that you don't want it to do. It's quite a tricky concept, because you might be thinking, well, how does a hacker put his or her code, malicious code, into my web page? Right? I wrote it. I've uploaded my web page to a server somewhere. I haven't given the credentials to access the server to anybody else. How does the hacker get his or her code into my web page? Well, we'll look at that. So cross-site scripting is where malicious script is injected either via a URL or a form field. So again, it may be the case that we have some form on our web page. We expect the user to type in some benign value, but instead they type in some code, some JavaScript code, and that code ends up being embedded in the web page and is subsequently executed. Okay. So in many ways, cross-site scripting is very similar to SQL injection. What is happening is that the hacker is able to inject malicious code that subsequently is executed, and whatever thing they're trying to, malicious thing they're trying to do succeeds. On the one hand, SQL injection, of course, the hacker is injecting malicious SQL code. With cross-site scripting, the hacker is injecting malicious JavaScript code, but the effect is the same. Now, in the case of SQL injection, what the hacker is endeavoring to do is potentially bypass security, or maybe destroy your database or steal data. In the case of cross-site scripting, the hacker is probably endeavoring to do something else. We'll look at examples of both. Now, the final of the three that we'll be looking at is cross-site request forgery. And this is still extremely common. In fact, I think if you were to look in your junk mail today, it's very likely that you'd find an email in there that is an attempt at cross-site request forgery. They are extremely common. So cross-site request forgery occurs when the user is tricked into issuing a request to some website or other. So you get an email with a link to your long lost relative in some distant country has passed away and has left you £1 million, and you need to click this link to claim it. Or you get an email, something a bit more believable, at least in my case. I get an email that appears to be from Screwfix telling me that I've won a prize draw and I've won a new DeWalt drill or something. And I think, oh, fantastic, I'll have that. Click the link, and before I know it, I'm in trouble. Now, cross-site request forgery relies upon the user being logged in to some website or other, some insecure website. And when the user clicks the link, they think they are going to one particular site, but in fact the link takes them somewhere else and attempts to perform some malicious operation on account of the fact that that user is currently logged into that site. Now, cross-site request forgery relies upon several technologies that we won't go into in detail, but one of the basic premises is that when you log into some site, you remain logged in for a period of time. It might be a day, it might be 7 days, or what have you. And within that window of time, unless you explicitly log out, you are susceptible to cross-site request forgery if the website if the web application has not been built securely. Okay, so all of these hacks, even though they've been around for decades, they are still as live today as they have ever been, particularly cross-site request forgery. So the demonstration, as I say, is a mix of looking at an insecure web application and looking at some code. So I hope you'll bear with me as I sort of jump between the requisite screens here. So as I said, the application, this little sample application, is written in Python, but of course the web pages themselves are HTML with a bit of other code, CSS and so on for styling purposes. You don't have to understand Python code to be able to see what is going on here. So let's jump over to the site itself. Here's my insecure web application, and it's currently running in vulnerable mode. So what I've done is built the application so that both the insecure and the secure code is sitting side by side, so that we can easily see the comparison between the bad and the good. Okay. It's obviously contrived for the purposes of the demonstration. So the login page is vulnerable to SQL injection. Profile and comments are vulnerable to stored cross-site scripting. That simply means that the malicious script is stored in my database. I've allowed the user to enter malicious code and I've stored it in my database. Search is vulnerable to reflected cross-site scripting, which is a little bit different. Reflected cross-site scripting means that I allow the user to enter some value and I immediately reflect that value back to the user. So I'll demonstrate that too. And transfer and comments are both vulnerable to cross-site request forgery. We have 3 users. We have an admin user, we have Bob and Carol. So I'm going to begin by logging in as the admin and doing it legitimately, so you can see what is available to the user once they are logged in. So let's go to login here. I'm going to type in admin, and the password for admin is pass123 in this case. So I sign in, and it works. The browser complains that my password is not very secure, but that's a browser thing. I can see that once I'm logged in, I have a profile page, I have a search page, I have a comments page with some comments that have been made by various users. I have a transfer page, a logout, and a link to reset the database here as well. Notice that each user has a balance and can transfer monies to another user. Okay, so we'll come back to that one a little later on. Now I'm going to log out and I'm going to make a change to the code so that when we log in, you can see the password. Okay, by default, the application is written such that, you know, when I type in the password box, I can't see the actual values. So let's change the code so we can see what is being entered there. I'm going to go to the login page here, I'm going to change the type of that text box from a password text box to a regular plain text text box. Okay, and by doing that, when I come back over here and do a refresh, when I type in that box, I can actually see what it is I'm typing. Okay. Now, if I type in admin username, the password is pass123. So if I type in the incorrect password, let's say 111, I would expect to be denied entry. Okay, I get a message saying that the credentials are invalid. But if I'm a malicious user and I suspect that the web application is not written particularly well or is not designed with security in mind, I might try to bypass the password altogether. And SQL injection enables me to do just that. If I know, as the malicious user, that there is a user called admin, then what I could do is type in that name as the password, as the username. But I could then type in a closing quotation mark, because I know that a SQL query includes quotation marks around user given values. And I could then effectively render the remaining part of the query redundant by adding the SQL comment marker, which is 2 hyphens. So I'm effectively saying that I know I'm effectively hacking the site to say, I know that there's a user called admin. I don't know admin's password, but I'm going to trick SQL into thinking the query ends halfway through, and I'm going to have it ignore the bit that checks the password. Okay? So the quotation mark effectively says end here, and then the comment says ignore everything that comes after. I can then type in any password I want and click sign in, and I'm in. Okay? That's how easy it is for a hacker who knows a little something about SQL to bypass authentication. Okay. Now, if we take a look at the vulnerable code here, we'll be able to see how this works in a little more detail. We jump over here and we look at our login function in our Python code. So this is it here. Now, this code includes both the secure and the insecure. And the insecure is this query here. I hope you can see that okay. You can see that it says select ID and username from the users table, where the username equals the user given username and the password is equal to the user given password. Now, the problem is that what the hacker did was enter a username and then the quotation mark. He then added the comment, the SQL comment character, which renders this part of the query irrelevant, and the database won't even check it. So the database will only look for a user with the given username and won't check the password at all. Consequently, the request is successful and the hacker gets in to the site. Now, the fix for this is pretty straightforward and has been around for a long time, and that is to execute the query in a slightly different way using what we call a prepared statement. So instead of embedding the user values directly into the query, we use these special placeholders. Okay, now it's a very minor alteration, but it makes a massive difference, because when we have the user given values embedded in that way, it effectively tells the database to separate the code from the user values, okay, and to sanitize those user values and not treat them as code. Okay, so all we need to do is switch from embedding the user values directly in the SQL to using a prepared statement, and that hack should not be possible. So let's test that out. I'm going to stop the application from running, and I'm going to restart it in secure mode so that we're using the prepared statement, the good code rather than the bad. And when I jump back over here, we'll log out. You can see that I'm now in secure mode. And when I go to my login page here, I'm going to try exactly the same thing, the same hack. So we're going to say admin and then the quotation mark and then the comment character to say to SQL, ignore everything that comes after. I enter any password, but I'm denied entry because the database is now separating the code from the user values, and the whatever the user entered is not treated as literal SQL code, and the hack fails. It's a very simple change, but massively important. Now, a lot of devs that I encounter are sort of vaguely aware of SQL injection, but they've never actually had to see it or encountered it at a low level like this, because they're using frameworks and tools that do a lot of the hard work for them. Now that's good, but it's also bad, I would suggest, because we want developers to understand these hacks. We want them to be able to test their software in this way to satisfy themselves that it is indeed secure. And these are things, of course, these are tests that can be automated through tools like Selenium and so on. So that's SQL injection. Let's put our application back into vulnerable mode, and we'll have a look at some cross-site scripting. Go back home. So we're back in vulnerable mode, and I'm going to log in. I'm going to log in this time as Bob. I haven't changed my password text box back to so we can still see the password here. That's okay. We can change that back later. So I'm going to sign in. I'm going to go to the comments page here. Now the comments page enables me both to see existing comments and also to post a new comment. So what we're meant to do, of course, is to enter a benign comment. Okay, I like coding or whatever. Okay, but a malicious user may attempt to or may see that we're going to take the comment entered and render it back in the page. Now that is a green light to a hacker to say, I can put some code in here that will be added to the web page. Okay, and if I enter code that is malicious, that malicious code is going to end up on the web page that everyone else sees. So all the malicious user has to do is know a bit of JavaScript code, and instead of entering a real comment, do something like this. So they might say, I'll enter an image, and we'll say the source of the image is X. Now the hacker knows that there's no image called X and that this will result in an error. So he can then exploit that to execute some JavaScript code. Now I'm going to do something relatively passive here. I'm going to display a little alert. You have been hacked. Okay. So all it requires is a malicious user with some knowledge of HTML and JavaScript code to embed malicious code into your web page. So let's post that, and you can see that the alert, the "you have been hacked" alert, pops up straight away. Okay, I can see the comment from Bob here with the image that doesn't exist. So Bob has now added his malicious code to the comments page, and every other user that encounters this page will encounter that hack. And just to prove that, I'm going to log out as Bob, and we'll log in again as admin. So admin logs in as normal, clicks on the comments page, and he has been hacked as well. Every user that visits this page is now susceptible to this malicious code that's been embedded by Bob. Okay? It's so easy for somebody who knows what they're doing to do something like this. Now, obviously, displaying a pop-up is not really, I mean, it's a bit annoying, but it's not really malicious. But the point is that the hacker can use this technique to embed any JavaScript code he or she wants. And that JavaScript code can do anything. It might introduce a denial of service. It may overwrite the contents of the page. It may steal information. It might initiate a keylogger to track what the user is doing. Anything. Okay. So how do we prevent it? Well, let's reset the database to get rid of that malicious comment, and we'll switch our application to secure mode. Actually, let's have a look at the code first of all before we do that. So we're interested in the adding of the comment. So if we take a look at the let's have a look at comments here. Yeah, so here I can see the code that takes the comment and inserts it into the database. And notice that the SQL here is good. It's using a prepared statement with the question marks, which is what we want. But even this is not going to protect us here, because it's not malicious SQL code that the hacker is injecting. It's malicious JavaScript code. Now, the database is not going to check for that. We have to check for that, okay? So one of the things that we could do to prevent this is to write some code here to check the values before we insert them into the database. That would be sensible. But another way that we can deal with this, and we would want to do that ideally, but another way we can deal with this is by going to the comments HTML page here. And in vulnerable mode, we are simply taking the user entered value, the comment, and embedding it in the HTML directly. So we're assuming the best. Whatever you type in, that's what we're going to render back. Okay? But the fix is to take that user entered value and sanitize it. That is to say, to look for malicious characters within what the user has typed and remove them or replace them. So in this case, the fix is to look for the chevrons, which are used to open and close the script element of the malicious code, and replace it with something benign, like the HTML special character. This is an easy fix, okay? But we've got to understand the hack in order to be able to apply it. So let's switch to secure mode, and then we'll try the hack again. So I'm going to stop that, and we'll run in secure mode this time. Back over here, we'll log in as Bob again. And we'll go to comments. Okay, so Bob's going to try the same trick again. He's going to import insert an image, a non-existent image that will trigger some JavaScript code. You have been hacked. like that. Whoops, that's in the wrong place. Like that. Okay. But this time, note that when he posts, we don't actually see the image. We see the literal value that he entered. Okay. So by replacing those chevrons in what Bob has entered, we're not actually embedding JavaScript code. We just have text that looks like code, and it doesn't do anything. Okay. What it does do is expose Bob as a hacker, because everyone can see that he's tried to embed malicious code into the web page, and he will get very embarrassed and delete his comment pretty quickly. Okay. If I log out and log in as admin, we'll see that the hack is unsuccessful when we go to comments too. But I can see that Bob has tried to do something malicious, and so we could blacklist him and whatever. Okay, so that's cross-site scripting. Let's quickly demonstrate cross-site request forgery, otherwise I'm going to occupy too much of your time. I'm going to reset my database, and we're going to flip back into vulnerable mode. Now this last one is arguably the, as I said, cross-site request forgery is still extremely common. So what I'm going to do is log in as admin. Okay, and I can see that admin's balance is 1,000. Okay. Now, admin may choose, whoever the admin is, may choose to transfer some money to some other user. So we're going to transfer £100 to Bob. Okay. So when I execute that, I can see the transfer is complete, and the balance for admin is now 900. If we were to log into Bob, we'd see that Bob's balance has grown. Now, admin is logged in. Okay, and he or she may go off and do other things and leave himself or herself logged in for a period of time. That's normal. We all do that. Cross-site request forgery happens when the user, in this case, is tricked into issuing a request to transfer some money, in this case. But it could be a link to do anything. So we've got another page here, an attacker page, which I'm going to load up. And we'll drop that in here so you can see it. Okay. So the user who is currently logged in to the site either visits another site or gets an email with a link in it to claim his reward or whatever the case may be. Now, he or she thinks that clicking this link is going to do one thing, but in fact it will do something else. And you can always you can actually spot a cross-site request forgery attack quite easily if you know what to look for. So when I hover over this link, if you look down in the bottom left-hand corner of the screen in very small text, you can see the URL that the link is going to issue a request to. And I can see it's going to issue a request to my insecure web app and to transfer £500 to Carol. Okay. Now, because I'm still logged in, because the user is still logged in, clicking that link is successful. And we have transferred £500 to Carol, and the admin's balance is now 400. Now, he or she panics at this point because we didn't expect to arrive at this page. So we think, oh my goodness, something has gone wrong. We assume it's not real, or we hope it's not real. So we log out and log back in, only to discover that in fact we've been hacked. Okay. Now, you might assume that the solution here is to log yourself out. And in a way, it is a good idea not to keep yourself logged in to important sites over a long period of time. But the site should not allow this to happen. It should not allow a request that comes from another site or from an email to initiate a write operation on the database like this. This is very bad. Okay. How do we fix it? Well, let's have a look at the code first of all. Now, it's a bit complicated here, and I don't want to get bogged down in the detail. But the problem is that the hacker knows everything he needs to know to do the hack. He knows that to initiate a transfer, he needs to trick the user to issuing a request to this URL. He knows that URL needs to include the name of the recipient and the amount to be transferred. And that's all he needs. He has all the information he needs to do this. Okay. The secret to overcoming cross-site request forgery is to require some additional information that the hacker cannot possibly know. Okay. So if we very briefly have a look at the transfer code here, which is here. In fact, the key information is here on. So the secret to preventing cross-site request forgery is to require a special token that is generated on a session-by-session basis. So for every session you log into your website, you are given a token that is exclusive and specific to your particular session on that website, and nobody else knows about that token, including the hacker. And when you issue a request to do a transfer, you must include that token. And if you don't, the website will refuse to do it. Okay? So the hacker can trick you into clicking a link, but it won't work because the hacker doesn't have that additional information. He doesn't have that token. There's no way he can get it. Okay? So to see this, I'm going to switch the application to secure mode one more time. We're going to we'll go back to our attacker page, and we'll reset our database here, and we'll log in as admin again. So I can see admin's balance is back at 5,000. Admin gets tricked, email, website, whatever it is, clicks on the link, but because the request issued from the email or from the malicious website doesn't include that additional information, that special token, the request is unsuccessful. Okay, I can see that the hacker has done all the right things in terms of his intention to hack. He has the right URL. He specified he wants to transfer £500 to Carol, but it doesn't work because he doesn't have that additional bit of information, that additional token. Okay. And you might say to me, well, Stuart, surely the hacker can obtain the token in the same way that he obtains information about the recipient and the amount. And the answer is no, because the token is only generated when the user visits the site, when the authentic user visits the site. Okay. And the token is there's not one token for everybody. There's one token per session. Okay. And so it's not possible that the hacker can steal it unless it's stored in a very insecure way. Okay. So we can see that the user still gets a shock because they end up on a site they didn't expect, but their balance has been unaffected by that attempt because the site is secure. Okay. The fix is pretty simple, but we've got to understand the hack in order to know to apply the fix. Okay. Okay. Let's jump back over here and just do a little review. I'm sorry, I've gone on perhaps a little longer than I ought to have. So SQL injection, cross-site scripting, and cross-site request forgery are very common attacks. They've been around for a long time, but they are as important today as they have ever been. Yes, there are a lot of tools, libraries, frameworks that help you to avoid these problems, but I think that developers must understand these hacks so that they can be active in ensuring that the code they are working on is secure, and that they don't inadvertently break the protections that are put in place. One more thing, very briefly, for you, a little bonus. OWASP is an organization, the Open Worldwide Application Security Project. There's a mouthful for you. These are the top 10 security vulnerabilities for 2025, so the last time they published. And I won't go through them all, but you'll notice that injection is still right up there at number 5. So this covers both SQL injection and cross-site scripting. And cross-site request forgery would arguably fall under insecure design. So even though these things have been around for years, they are still causing organizations problems. And they are fundamental things that every developer working on web applications ought to be familiar with. They ought to know how to hack their own sites to ensure that they are protected. Okay. And with that, I'll hand back to Eddie. Apologies for running over time a little.
That's okay. We're still within the time, so you're all good. I'll just keep my bit sweet and short. So thank you all again for joining the webinar today. I don't believe we've had any questions yet, but if you do have any questions, please feel free to pop those in the box. We have still got sort of 10 minutes or so, so we do have a bit of time to pick those up if you have any. As I mentioned earlier in the session, we will send over an email on Monday with a link to the full recording, so you can watch this back or send it on to anybody else that you think might find it useful. You can find out more about our courses on our website. We do have a range of programming web development courses, which you may find useful. Or if you do have any questions about which course might be right for you, or generally about our study options, that kind of thing, you can also get in touch with the team and they will be happy to discuss. Stuart has kindly put his email address on the presentation, so if you do have any questions about the session today, I'm sure he'd be happy to answer those. And yeah, thank you again for joining us. I think we're all good. We don't seem to have had any questions. You've obviously covered everything people wanted to know, Stuart. So I think we'll leave it there for today. Thanks again for joining, and we hope you all have a lovely rest of your day.